While I have been putting this new CD2H series displacement laser measurement sensor from Optex FA through its paces, I came across kind of a unique feature I wanted to talk about. It's the edge detection measurement mode. And what's really cool about this function is that the sensor can be configured to detect specific changes in the measured distance values associated with the rising or trailing edges of a target or a combination of both. Once you select the edge mode, you set the sensor a minimum edge height and a maximum edge height difference and the direction of the edge pulse. So if you have parts that are overlapped or stair-stepped, you can count them accurately. You could also have parts with varied size characteristics, or if there are gradual changes that you want to ignore, like a slope, and only detect an edge transition, this function could be useful. In this example, I set the sensor up to only detect a 2.5 millimeter step height change in one direction. For fun, I hooked the NPN output to this little microcontroller and then connected these really awesome industrial hardened LED strip lights from Banner Engineering, it's the WLF series. Generally, you would connect them to an adapter that will allow for like a 24 volt DC IO link or discrete IO. But figured I would see if I could address it using a MicroPython library. The sensor will output in this direction, but not in this direction, at least until it sees pulse in the opposite direction. You could also set up a second output, so one output is looking for positive edges of 2.5 millimeters and negative edges of the same or different distances, and you could use it to determine if the line has stopped or is moving. If the parts are continuously providing edges in a positive or negative direction, like the stair step, you could do forward and backwards. Although very uncommon, it's interesting to think about the potential of this feature in various applications. Any ideas come to mind? For more information, visit our website at www.ramcoi.com.